Hi, I'm Cody Ryder, and I'm part of the team for the miniature train. The other two members are Alexander Van Kampen and Lawrence Naidu. So the purpose of this project, as the traffic continues to get worse in every city in the country and around the world, as more people are buying cars, a new form of transportation is warranted to ease this burden. We propose a self-propelled pod capable of safely transporting cargo of any kind, safely and quickly. For this project, we will design some of the various control systems we'll need for a full version of the pod. The pod should be able to read the distance it has from the wall at the end and stop before hitting it, stop itself if it ever tips over, provide data on its situation to a web page, and be capable of activation from that web page. If completed, this project will make a good structure to build off of when designing the full pod. So the hardware that we have here, we have the Raspberry Pi speed controller, hobby motors, the IMU ultrasonic rangefinder, the PiCan 2 Arduino Uno, some a 1K ohm resistor, jumper wires, 11 AA batteries, a Kunki motor driver, a motor driver controller, and a 5-volt double port battery pack. The project contributions, I was in charge of the CAN bus network, Lawrence Naidu was in charge of IMU and ping sensor, and Alexander was working on the motor control and web browser interface. The ultrasonic rangefinder, this sensor records distance and is programmed to send a stop signal to the motors when it comes closer to a certain distance to the wall. The IMU, the sensor records its orientation. It is programmed to send a stop signal to the motors if it does happen to flip over. The CAN bus, in this application, the RPi connected to the ping sensor will send a CAN message once the vehicle approaches a wall. This message will be received by the other RPi and output logic to turn off the motors. Here's the receive code, and it's integrated with the output to the motors to turn it off. And here's the transmit code, which is integrated with the ping sensor, so when it gets in range, it's going to turn off the motors. The RPi web browser interface, the other RPi will be the host of the web server capable of activating specific GPIO pins on the RPi. Only one pin will be needed for activating the motor control. And there is the code for that. And also the code for the HTML code. The motor control for this, we used Arduino Uno board paired with two H-bridge boards so as to control 4 3-volt DC motors in order to propel the pod. And the motor control code. And here's our overall setup. And here's our demonstration.
Okay, one sec. There we go. Okay. Hit the ping. There's the measurements. Okay. Bam.
Alright, so what we saw the motors running as soon as he activated the button on the web browser, and we had measurements on the other laptop, and when we put our hand in front of the sensor within the 40 centimeter range that we set up, the motors would cut the power. So in conclusion, we designed this project as a test platform for a transportation system that will need to propel itself vast distances. For this platform, we focused on the safety protocols, making sure it knows when to stop, when it's too close to the wall, and shutting itself down when it starts to tip. We also added a simple remote activation interface. Thanks for watching.